Close your eyes and imagine the vastness of space, the solar system in its infancy, a swirling disk of gas and dust, sunlight just beginning to shine from a newborn star. In this cosmic nursery, not only are planets being born, but so too are their companions, the moons. These natural satellites, each with their own story, are as diverse and fascinating as the worlds they orbit. Their origins are written in the language of gravity, collision, and cosmic chance. Moon, or natural satellites, are found around almost every major planet in our solar system. Mercury and Venus are the only exceptions, their proximity to the Sun and their own histories leaving them moonless. But for the rest, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, the story of moons is a story of abundance and variety. Some planets have just one, like Earth. Others, like Jupiter and Saturn, have dozens, each with its own path, its own rhythm, its own secrets. How do moons come to be? Their origins can be traced to three main processes: co-formation, capture, and collision. The first process, co-formation, is the story of siblings born together. In the early solar system, as planets formed from the disk of gas and dust around the Sun, smaller disks formed around the giant planets. Within these miniature solar systems, material clumped together, forming moons in orbit around their parent planet. This is how the largest moons of Jupiter and Saturn, Ganymede, Callisto, Io, Europa, Titan, and others came to be. They are made of the same stuff as their planets, a mix of rock and ice, and their orbits are nearly circular, lying in the planet's equatorial plane. These moons are the true children of their worlds, their histories intertwined from the very beginning. The second process, capture, is the story of wanderers and chance encounters. Sometimes a planet's gravity snags a passing asteroid or comet, pulling it into orbit. This is how many of the irregular, distant moons of Jupiter, Saturn, Uranus, and Neptune were acquired. Their orbits are often eccentric, tilted, or even retrograde, moving in the opposite direction of the planet's rotation. Mars's two tiny moons, Phobos and Deimos, are thought to be captured asteroids. Their shapes irregular, their surfaces battered by impacts. Neptune's largest moon, Triton, is also believed to be a captured object, its retrograde orbit a clue to its outsider origins. The third process, collision, is the story of violence and rebirth. Sometimes a giant impact shatters a planet or a large body, sending debris into space. This debris can coalesce into a new moon, born from the wreckage of catastrophe. Earth's moon is the most famous example. Billions of years ago, a Mars-sized body struck the young Earth, blasting material into orbit. Over time, this material gathered and clumped, forming the moon we see today. Pluto's large moon, Charon, may have formed in a similar way, the result of a collision in the distant Kuiper belt. These three processes, co-formation, capture, and collision, explain the diversity of moons in our solar system. Some are large and round, with active geology and atmospheres. Others are small and irregular, little more than captured rocks. Some are icy, hiding oceans beneath their crusts. Others are rocky, covered in craters and dust. Some are volcanically active, like Io, with geysers and lava flows. Others are dead and silent, unchanged for billions of years. The diversity of moons is astonishing. Jupiter's Ganymede is the largest moon in the solar system, bigger than Mercury, with a magnetic field and a surface of ice and rock. Saturn's Titan is the only moon with a thick atmosphere, its surface sculpted by rivers and lakes of methane and ethane. Enceladus, another of Saturn's moons, hides a global ocean beneath its icy shell, its geysers feeding Saturn's E-ring with fresh material. Neptune's Triton has geysers of nitrogen, its surface a patchwork of frozen lakes and strange terrain. Some moons are locked in resonance, their orbit linked in simple ratios, their paths intertwined in a cosmic harmony. Jupiter's moons, Io, Europa, and Ganymede, are locked in a 1-2-4 resonance, their gravitational tugs heating their interiors, driving volcanic and tectonic activity. Saturn's moons, Prometheus and Pandora, shepherd the F-ring, their gravity creating knots and braids, shaping the structure of the rings. Moons are not just passive companions, they shape their planets in profound ways. Earth's moon stabilizes our planet's tilt, moderates the climate, and creates the tides that shape the oceans and the life within them. Jupiter's moons drive volcanic activity, create magnetic fields, and even influence the planet's radiation belts. Saturn's moons feed the rings, create waves and gaps, and may even harbor life in hidden oceans. The story of moons is also a story of discovery. For centuries, only Earth's moon was known, its phases and movements tracked by every culture, its face mapped and named, its influence woven into myth and science. Then, with the invention of the telescope, the moons of Jupiter were discovered by Galileo, followed by the moons of Saturn, Uranus, and Neptune. Each new moon was a revelation, a new world to explore, a new piece of the cosmic puzzle. Today, spacecraft have visited many of these moons, sending back images and data that reveal their true nature. We have seen the icy plumes of Enceladus, the methane lakes of Titan, the volcanoes of Io, the canyons of Miranda, the geysers of Trident. We have learned that moons are not just rocks in space, but worlds with their own geology, their own weather, their own potential for life. As you rest in this gentle night, let yourself imagine the dance of the moons. Picture them circling their planets, moving in silence, their paths set by gravity, their rhythms shaped by time. Imagine the diversity of their worlds, the ice and rock, the mountains and oceans, the volcanoes and geysers, the craters and plains. Let yourself wonder what it would be like to stand on the surface of a moon, to look up and see your planet filling the sky, to watch the sun rise and set in strange patterns, to feel the pull of gravity, the beauty of the dance. Imagine the peace that comes with patience, the wonder that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. The moons are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony and connection, in the power of nature to create order from chaos. Take another breath. Let the story of the moons fill you with calm. Let the slow, patient movement of the satellites remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of the moons, a dreamer in the endless night. Close your eyes and imagine the vastness of space, where planets and moons drift in a silent, endless ballet. In this cosmic dance, nothing is random. Every moon that circles a planet is held in place by an invisible thread of force that binds, balances, and shapes the very structure of the solar system. This is the gravitational bond, a quiet power that keeps moons in orbit and creates the harmony of the heavens. Gravity is the most familiar force in our lives. It's what keeps your feet on the ground, what makes a ball fall, what gives weight to your body. But in space, gravity is the architect of worlds, the sculptor of orbits, the composer of the cosmic symphony. It is the reason moons exist at all, the reason they circle their planets, the reason the solar system is a place of order and not chaos. Imagine a moon, newly formed or newly captured, drifting near a planet. The planet's gravity reaches out, pulling on the moon, trying to draw it closer. But the moon is moving, gliding through space with its own speed and direction. If the moon moves too slowly, gravity wins, the moon spirals inward, crashing into the planet or being torn apart by tidal forces. If the moon moves too quickly, it escapes, flying off into the darkness, lost to the planet forever. But if the moon's speed is just right, a balance is struck. The moon falls toward the planet, but its motion carries it forward, so it keeps missing the planet, falling around it instead of into it. This is an orbit, a path that is both a fall and a flight, a perfect compromise between gravity and motion. The moon is bound to the planet, but always moving, always free, always in motion. The shape of a moon's orbit depends on its speed, its distance from the planet, and the influence of other bodies. Most moons follow nearly circular orbits, their paths smooth and steady, their distance from the planet almost constant. Some moons, especially those that were captured, follow more eccentric orbits, ellipses, that bring them close to the planet at one end and far away at the other. The farther a moon is from its planet, the slower it moves, the longer its orbit takes. The gravitational bond is not just a matter of distance and speed, it is a relationship, a partnership, a dance. The planet pulls on the moon, but the moon also pulls on the planet. This mutual attraction creates tides, wobbles, and even changes in the planet's rotation. Over time, the energy of the system is exchanged. transferred and transformed, creating new patterns, new rhythm, new possibilities. One of the most beautiful consequences of the gravitational bond is tidal locking. Over millions of years, the gravity of the planet slows the rotation of the moon until the same side always faces the planet. This is why we always see the same face of our moon, why one hemisphere is forever turned toward Earth, while the other is hidden in eternal night. Tidal locking is a sign of intimacy, of connection, of the slow, patient work of gravity. But the gravitational bond is not always gentle. Sometimes the pull of gravity is too strong, and a moon that ventures too close to its planet is torn apart, its material spreading out to form rings, its story ending in destruction and renewal. The Roche limit is the boundary within which a moon cannot survive intact, a line drawn by gravity, a reminder of the power and danger of the bond. The gravitational bond is also the reason moons can be captured. When a wandering asteroid or comet passes near a planet, gravity can slow it down, robbing it of energy, pulling it into orbit. The new moon may have a strange, tilted, or even retrograde orbit, a sign of its outsider origins, a record of a chance encounter in the darkness. The gravitational bond is not just a force, it is a source of beauty. It creates the patterns of orbits, the cycles of eclipses, the harmony of resonances. It is the reason moons can shepherd rings, create gaps, and carve waves in the icy bands around Saturn. It is the reason moons can heat their interiors, drive volcanoes and geysers, and perhaps even create the conditions for life. The gravitational bond is also a source of stability. Moons can help stabilize the tilt of their planet, moderating the climate, creating regular seasons, and making life more likely. Earth's moon is a perfect example. Without it, our planet's tilt would wobble chaotically, the climate would swing wildly, and life as we know it might never have arisen. But the gravitational bond is also a source of change. Over time, the energy of the system is exchanged, and orbits evolve. Some moons spiral outward, moving away from their planet as tidal force transfer energy from the planet's rotation to the moon's orbit. Others spiral inward, doomed to one day crash or be torn apart. The dance is never static, never finished, always unfolding. As you rest in this gentle night, let yourself imagine the gravitational bond between a planet and its moon. Picture the invisible thread that connects them, the balance of pull and motion, the harmony of the orbit. Imagine the peace that comes with stability, the beauty that comes with connection, the wonder that comes with knowing that you are part of a universe where every world is held in place by the quiet power of gravity. Let yourself wonder what it would be like to float between a planet and its moon, to feel the tug of gravity, the pull of the bond, the beauty of the dance. Imagine the patience of the orbits, the endurance of the cycles, the hope that comes with knowing that you are part of a story that is both ancient and ever new. The gravitational bond is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony, in connection, in the power of nature to create order from chaos. Take another breath. Let the story of gravity fill you with calm. Let the slow, patient movement of the moons remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of gravity and moons, a dreamer in the endless night. Close your eyes and imagine the ocean at dawn. The water is calm, the air is cool, and the horizon glows with the promise of a new day. But look closer and you'll see that the sea is never truly still. It rises and falls, breathes in and out in a rhythm as old as the world itself. This is the tide, a gentle, powerful movement of water, driven by the invisible hand of gravity, the pull of the moon, the dance of celestial bodies across the sky. Tides are one of the most beautiful and subtle effects of gravity in the universe. They are a reminder that even the most distant objects can shape our world, that the moon hanging in the sky can move entire oceans, sculpt coastlines, and influence the lives of every creature on Earth. But how does this happen? What is the secret of tidal forces, and how do they connect the moon and its parent planet in a dance that never ends? The story of tides begins with gravity. Every object in the universe pulls on every other object. The strength of the pull, depending on their masses and the distance between them. The moon is much smaller than Earth, but it is close, just 384,000 kilometers away. a neighbor in cosmic terms. Its gravity reaches out, pull, ng on the Earth, tugging at the oceans, creating a bulge of water on the side of the planet facing the moon. But gravity is not uniform. The side of Earth closest to the moon feels a stronger pull than the center, and the center feels a stronger pull than the far side. This difference in gravitational pull stretches the Earth slightly, create two bulges, one on the side facing the moon, and one on the opposite side. As the Earth rotates, these bulges move around the planet, creating the rise and fall of the tides. The result is a cycle of high and low tides, repeating every 12 hours and 25 minutes. As the Earth spins, any given point on the coast passes through both bulges, experiencing 2 high tides and 2 low tides each day. The timing and height of the tides depend on the position of the moon, the shape of the coastline, the depth of the ocean, and the influence of the sun, which also creates its own smaller tides. The sun's gravity is much stronger than the moon's, but it is also much farther away. Its tidal effect is about half that of the moon, but when the sun and moon are aligned during new and full moons, their forces combine, creating especially high and low tides called spring tides. When the sun and moon are at right angles during the first and third quarters, their forces partially cancel, creating neap tides, which are less extreme. Tides are not just a feature of Earth. They are a universal consequence of gravity, found wherever a moon orbits a planet, W. Herever 2 bodies are close enough for their gravity to interact. On Jupiter's moon Io, tidal forces from Jupiter and the other Galilean moons create friction and heat, driving volcanic eruptions that make Io the most geologically active world in the solar system. On Saturn's moon Enceladus, tides flex the icy crust, heating the interior, creating geysers that spew water into space and feed Saturn's E-ring. Tidal forces can also shape the orbits and rotations of moons and planets. Over time, the energy of the tides is transferred from the rotation of the planet to the orbit of the moon, causing the moon to move farther away and the planet's rotation to slow. This is why the moon is slowly receding from Earth about 3.8 centimeters per year, and why Earth's day is gradually getting longer. Tidal forces can even lock a moon's rotation to its orbit, a process called tidal locking. This is why we always see the same face of the moon, why one hemisphere is forever turned toward Earth, while the other is hidden in eternal night. Tidal locking is a sign of intimacy, of connection, of the slow, patient work of gravity. Tides have shaped the history of our planet in profound ways. They have sculpted coastlines, created estuaries and tidal flats, influenced the evolution of life, and guided the migrations of animals. The rhythm of the tides is woven into the fabric of life, a cycle that connects the moon, Earth, and the sea in a dance that never ends. Tides have also inspired wonder and curiosity. For centuries, people have watched the rise and fall of the sea, tracked the cycles of the moon, and tried to understand the connection. The ancient Greeks and Romans noticed the link between the moon and the tide, but it was not until Isaac Newton that the true cause was understood. A triumph of science, a revelation of the power of gravity. As you rest in this gentle night, let yourself imagine the dance of the tides. Picture the moon rising over the ocean, its gravity pulling at the water, creating a bulge that moves around the planet. Imagine the sun joining the dance, its gravity adding to or subtracting from the tides, creating cycles of spring and neap tides. Imagine the slow, patient movement of the water, the rise and fall, the ebb and flow, the beauty of the rhythm. Let yourself wonder what it would be like to stand on a distant moon, to feel the pull of a giant planet, to watch the tides rise and fall, to see the surface flex and crack, to witness the power of gravity at work. Imagine the peace that comes with patience, the wonder that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Tidal forces are a reminder that every world is connected, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the tides is a lesson in harmony and connection, in the power of nature to create order from chaos. Take another breath. Let the story of the tides fill you with calm. Let the slow, patient movement of the water remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of the tides, a dreamer in the endless night. Close your eyes and imagine the moon high above the horizon, glowing softly in the night sky. Night after night, month after month, you notice something curious. The same face of the moon always looks down on you. The dark seas and bright highlands, the familiar pattern of craters and shallows never change. The man in the moon is always there, watching, silent and serene. Why is this? Why does the moon never turn, never show us its far side? The answer lies in one of the most beautiful and subtle dances in the cosmos, a phenomenon called tidal locking. Tidal locking is the reason many moons, including our own, always show the same face to their planet. It is a consequence of gravity, of time, and of the slow, patient exchange of energy between two worlds. To understand tidal locking, we must first understand tides themselves. When a moon orbits a planet, the planet's gravity pulls on the moon, stretching it slightly, creating a bulge on the side facing the planet and another on the far side. If the moon is spinning at a different rate than it orbits, these bulges are not aligned with the planet. The planet's gravity then tugs on the bulges, trying to pull them into ally. This creates a torque, a twisting force that acts to slow down the moon's rotation. Over millions or billions of years, this torque gradually changes the moon's spin, slowing it down until its rotation period matches its orbital period. At this point, the same side of the moon always faces the planet, and the system is said to be tidally locked. The process is slow, but relentless, a gentle, patient sculpting by gravity, dance that ends in perfect harmony. Our moon is tidally locked to Earth. It rotates once on its axis every 27.3 days, the same time it takes to orbit Earth. As a result, we always see the same hemisphere, the near side, while the far side remains hidden, revealed only by spacecraft. The moon's tidal bulges are now aligned with Earth, and the torque has vanished. The dance is complete, the rhythm set, the pattern unchanging. Tidal locking is not unique to our moon. It is common throughout the solar system. Wherever a moon orbits close to its planet, most of Jupiter's and Saturn's large moons are tidally locked, always showing the same face to their parent world. Pluto and its moon Charon are mutually locked, each always showing the same face to the other. Their dance is slow, patient waltz. Tidal locking can also affect planets. Mercury, for example, is in a 3-2 resonance with the Sun. It rotates 3 times. For every 2 orbits, a compromise between tidal locking and its own eccentric orbit. Many exoplanets, especially those close to their stars, are thought to be tidally locked, with one side in perpetual day and the other in eternal night. The consequences of tidal locking are profound. On a tidally locked moon, one hemisphere always faces the planet, bathed in its light, while the other faces away, lost in darkness. The near side of the moon is marked by large, dark Maria, ancient lava plains, while the far side is more heavily cratered, its surface shaped by a different history. The climate, geology, and even the potential for life on a tidally locked world are shaped by this unchanging relationship. Tidal locking also creates a sense of intimacy, of connection, of partnership. The moon and planet are bound together, their rhythms synchronized, their fates intertwined. The same face of the moon has watched over Earth for billions of years, its features familiar to every generation, its presence a constant in the changing sky. But tidal locking is not the end of the story. The process continues slowly and subtly as energy is exchanged between the planet and the moon. On Earth, the moon's gravity creates tides in the oceans, which in turn create friction, slowing Earth's rotation and causing the moon to drift away at a rate of about 3.8 centimeters per year. In the distant future, Earth's day will be as long as the moon's orbit, and both will be tidally locked, always showing the same face to each other, a final, perfect harmony. Tidal locking is a reminder that the universe is a place of patience, of endurance, of slow, subtle change. It is a process that takes millions or billions of years, a dance that ends in stillness, a story that is both ancient and ever new. As you rest in this gentle night, let yourself imagine the dance of tidal locking. Picture the moon circling Earth, its rotation slowing, its bulges aligning, its face settling into a permanent gaze. Imagine the moons of Jupiter and Saturn, each locked to its planet, each showing the same face, each moving in perfect rhythm. Imagine the exoplanets, tidally locked to their stars, their days and nights eternal, their climates shaped by the unchanging light. Let yourself wonder what it would be like to stand on the surface of a tidally locked moon, to look up and see your planet always in the same place in the sky, to know that one side of your world is forever turned toward home, while the other is lost in darkness. Imagine the peace that comes with patience, the beauty that comes with connection, the hope that comes with knowing that you are part of a universe where every world is shaped by the quiet power of gravity. Tidal locking is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony, in connection, in the power of nature to create order from chaos. Take another breath. Let the story of tidal locking fill you with calm. Let the slow, patient movement of the moons remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of tidal locking, a dreamer in the endless night. Close your eyes and imagine a world far from the warmth of the sun and moon, circling a giant planet in the cold, dark reaches of the solar system. You might expect such a place to be frozen and silent, a world of ice and stillness. But as you draw closer, you see something astonishing: volcanoes erupting, geysers spraying water into space, the surface alive with energy and change. This is the paradox of tidal heating, a process where gravity, not sunlight, becomes the engine of fire and motion. Tidal heating is one of the most remarkable consequences of gravity's dance. It happens when a moon's orbit is not perfectly circular but slightly stretched into an ellipse. As the moon moves closer to and farther from its planet, the gravitational pull changes, flexing the moon's interior, squeezing and stretching it like a ball of clay. This constant flexing creates friction, and friction creates heat enough to melt rock, drive volcanoes, and keep oceans liquid beneath a shell of ice. The most dramatic example of tidal heating in our solar system is Io, the innermost of Jupiter's 4 large Galilean moons. Io is a world of fire, its surface covered in hundreds of active volcanoes, its air thin and yellow with sulfur. The reason for this volcanic fury is the relentless pull of Jupiter's gravity, combined with the tugs of its neighboring moons, Europa and Ganymede. Io's orbit is kept slightly eccentric by these gravitational interactions, so it is constantly flexed and squeezed, its interior heated to the point of melting. The result is a world in perpetual eruption. Lava fountains shoot kilometers into the sky. Lakes of molten rock bubble and churn. Plumes of sulfur and ash rise above the surface, painting Io in shades of yellow, orange, and red. The landscape is ever-changing, the surface renewed again by volcanic flows. Io is the most volcanically active body in the solar system, a place where gravity's invisible hand creates a world of fire in the cold of space. But tidal heating is not limited to rocky moons. It is also at work on icy worlds, where it creates a different kind of wonder. Enceladus, a small moon of Saturn, is a world of ice and water, its surface bright and smooth, its south pole marked by long blue fractures called tiger stripes. From these fractures, geysers of water and ice erupt into space, creating a plume that feeds Saturn's ring and hints at a hidden ocean beneath the ice. The source of Enceladus's heat is tidal flexing. As the moon orbits Saturn, its path is slightly eccentric, kept that way by the gravitational influence of the larger moon Dia. The changing pull of Saturn's gravity flexes Enceladus's interior, generating enough heat to melt ice, create a subsurface ocean, and drive the geysers that spray water into space. The discovery of these plumes by the Cassini spacecraft was one of the most exciting moments in planetary science, a sign that even in the coldest places there can be warmth, motion, and perhaps even life. Tidal heating is also at work on other moons. Europa, another of Jupiter's moons, is covered in a shell of ice, but beneath that shell is a global ocean, kept liquid by the same process of gravitational flexing. The surface of Europa is crisscrossed by cracks and ridges, evidence of the stresses and strains created by tides. Ganymede and Callisto, the other Galilean moons, also show signs of past or present tidal heating, their interiors shaped by the slow, patient work of gravity. The process of tidal heating is a reminder that energy can come from unexpected places. In the inner solar system, the sun is the main source of heat, driving weather, shaping climates, powering life. But in the outer solar system, where sunlight is weak and the cold is deep, gravity takes over, creating worlds of fire and water, of volcanoes and oceans, of change and possibility. Tidal heating also has profound implications for the search for life. On Earth, Life thrives wherever there is energy and water, from the sunlit surface to the dark depths of the ocean. On moons like Enceladus and Europa, tidal heating provides both, keeping oceans liquid, driving chemical reactions, creating environments where life could exist, even in the absence of sunlight. The plumes of Enceladus, rich in organic molecules, are a tantalizing hint that life's story may not be limited to Earth. As you rest in this gentle night, let yourself imagine the power of tidal heating. Picture Io's volcanoes erupting in the darkness, Enceladus's geysers spraying water into space, Europa's ice cracking and shifting above a hidden sea. Imagine the warmth that comes from within, the energy that comes from motion, the beauty that comes from the quiet dance of gravity. Let yourself wonder what it would be like to stand on the surface of Io, to feel the ground tremble with the force of an eruption, to see the sky filled with plumes of fire and ash. Imagine drifting above Enceladus, watching the geysers rise and fall, feeling the hope that comes with knowing that even in the coldest places there can be warmth, motion, and light. Tidal heating and volcanic moons are a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places, that wonder is never far away. They are a symbol of patience, of endurance, of the power of nature to create order from chaos. Take another breath. Let the story of tidal heating fill you with calm. Let the slow, patient movement of the moons remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of tidal forces and volcanic moons, a dreamer in the endless night. Close your eyes and imagine a day when the world changes. The sun climbs high in the sky, its light warm and familiar, when suddenly a shadow begins to creep across its face. The sky darkens, the air cools, the birds fall silent. For a few precious moments, day becomes night, and the sun is hidden behind a perfect black disk, its corona glowing in a halo of silver fire. This is a solar eclipse, a cosmic alignment, a moment when the dance of the moon and the earth and the sun creates one of nature's most breathtaking spectacles. Eclipses are the result of perfect geometry, of orbit and shadows, of the quiet, patient movement of celestial bodies. They are a reminder that the universe is a place of order and pattern, of cycles and repetition, of beauty that comes from alignment and chance. A solar eclipse occurs when the moon passes directly between the Earth and the sun, casting its shadow on the surface of our planet. The moon is much smaller than the sun, but it is also much closer, so close, in fact, that it can cover the sun's disk almost exactly, creating a moment of totality when the sun is completely hidden. The coincidence is remarkable. The sun is about 400 times larger than the moon, but also about 400 times farther away, making their apparent sizes in the sky nearly equal. There are three main types of solar eclipses. In a total solar eclipse, the moon completely covers the sun and the sky darkens as if it were night. The stars come out, the temperature drops, and the sun's corona, a halo of hot, glowing gas, becomes visible, a sight of ethereal beauty. In a partial solar eclipse, only part of the sun is covered, creating a crescent of light. In an annular eclipse, the moon is slightly farther from Earth, so it appears smaller in the sky, and a ring of sunlight remains visible around the moon, a ring of fire. Solar eclipses are rare for any given location because the moon's orbit is tilted by about 5 degrees relative to Earth's orbit around the sun. Most of the time, the moon passes above or below the sun and no eclipse occurs. Only when the orbits align perfectly does the moon's shadow fall on Earth, creating a path of totality that is often just a few hundred kilometers wide. A lunar eclipse is a different kind of alignment. Here, the Earth passes between the sun and the moon, casting its shadow on the moon's surface. As the shadow moves across the moon, it turns a deep, coppery red, a blood moon, as sunlight passing through Earth's atmosphere is bent and scattered, filtering out the blue and leaving only the red. Lunar eclipses can be total, partial, or penumbral, depending on how much of the moon passes through Earth's shadow. Lunar eclipses are more common than solar eclipses, and they can be seen from anywhere on the night side of Earth. They are slower, more patient, lasting for hours as the shadow moves across the moon's face. They are a reminder that the Earth, too, casts a shadow, that we are part of the cosmic dance, that our world is not the center, but a participant in it. Cycles of light and darkness. Eclipses have inspired awe and wonder for as long as humans have watched the sky. Ancient peoples saw them as omens, messages from the gods, moments of magic and fear. Stories and myths grew around them, dragons devouring the sun, spirits stealing the moon, battles between light and darkness. Priests and astronomers learned to predict eclipses, to read the patterns in the sky, to turn fear into knowledge, wonder into science. Today, eclipses are moments of celebration and discovery. People travel across continents to stand in the path of totality, to witness the sun's corona, to feel the hush of the world as day becomes night. Scientists use eclipses to study the sun's atmosphere, to test the laws of gravity, to search for new phenomena. Photographers and artists capture the beauty, the drama, the fleeting perfection of the alignment. But eclipses are not just a spectacle. They are a lesson in perspective. They remind us that we live on a moving world, circling a star, accompanied by a moon. They show us the power of geometry, the beauty of cycles, the wonder of chance. They are a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places. That wonder is never far away as you rest in this gentle night. Let yourself imagine the dance of eclipses. Picture the moon moving between the earth and the sun, casting its shadow on the land, turning day into night, revealing the hidden corona. Imagine the earth passing between the sun and the moon, its shadow turning the moon red, marking the passage of time, the rhythm of the cosmos. Let yourself wonder what it would be like to stand in the path of totality, to feel the world grow quiet, to see the stars come out in the middle of the day, to witness the beauty of alignment, the perfection of the cosmic dance. Imagine the peace that comes with patience, the wonder that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Eclipses are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony, in connection, in the power of nature to create order from chaos. Take another breath. Let the story of eclipses fill you with calm. Let the slow, patient movement of the shadows remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of eclipses, a dreamer in the endless night. Close your eyes and imagine a bright, cloudless day. The sun is high, the world is warm, and the sky is a brilliant blue. Suddenly, a shadow begins to creep across the sun's face. The light grows dim, the air cools, and a hush falls over the land. For a few precious moments, the day becomes night, and the sun is hidden behind a perfect black disk, its core glowing in a halo of silver fire. This is a solar eclipse, one of nature's most dramatic and awe-inspiring spectacles. A solar eclipse is a cosmic alignment, a moment when the moon passes directly between the earth and the sun, casting its shadow on the surface of our planet. The moon is much smaller than the sun, but it is also much closer, so close, in fact, that it can cover the sun's disk almost exactly, creating a moment of totality when the sun is completely hidden. The coincidence is remarkable. The sun is about 400 times larger than the moon, but also about 400 times farther away, making their apparent sizes in the sky nearly equal. The mechanics of a solar eclipse are a dance of orbits and shadows. The moon's orbit around Earth is tilted by about 5 degrees relative to Earth's orbit around the sun. Most of the time, the moon passes above or below the sun, and no eclipse occurs. But about 2 to 5 times a year the orbits align perfectly, and the moon's shadow falls on Earth, creating a path of totality that is often just a few hundred kilometers wide. There are 3 main types of solar eclipses. In a total solar eclipse, the moon completely covers the sun, and the sky darkens as if it were night. The stars come out, the temperature drops, and the sun's corona, a halo of hot, glowing gas, becomes visible, a sight of ethereal beauty. In a partial solar eclipse, only part of the sun is covered, creating a crescent of light. In an annular eclipse, the moon is slidal, farther from Earth, so it appears smaller in the sky, and a ring of sunlight remains visible around the moon, a ring of fire. The beauty of a total solar eclipse is unlike anything else in nature. As the moon's shadow sweeps across the land, the world changes. The light grows strange, the colors shift, the temperature drops. Animals grow quiet, Birds return to their nests, flowers close their petals. The sun's corona, usually hidden by the glare of daylight, appears as a crown of silver and white, its tendrils stretching out into space, its structure shaped by the sun's magnetic field. For a few minutes, the world is transformed. The ordinary becomes extraordinary, the familiar becomes mysterious. The boundaries between day and night, light and shadow, are blurred. The experience is both humbling and exhilarating, a reminder of the power and beauty of the universe, a moment of connection to the cosmos. Solar eclipses have inspired awe and wonder for as long as humans have watched the sky. Ancient people saw them as omens, messages from the gods, moments of magic and fear. Stories and myths grew around them, dragons devouring the sun, spirits stealing the light, battles between good and evil. In China, people would bang drums and shoot arrows into the sky to scare away the dragon. In ancient Greece, eclipses were seen as signs of the gods' displeasure, warnings of disaster or change. But solar eclipses have also been moments of discovery and understanding. The ancient Babylonians and Greeks learned to predict eclipses, to read the pattern in the sky, to turn fear into knowledge, wonder into science. See, in 1919, a total solar eclipse provided the first experimental confirmation of Einstein's theory of general relativity, as astronomers measured the bending of starlight by the sun's gravity. Today, solar eclipses are moments of celebration and exploration. People travel across continents to stand in the path of totality, to witness the sun's corona, to feel the hush of the world as day becomes night. Scientists use eclipses to study the sun's atmosphere, to search for new phenomena, to test the laws of physics. Photographers and artists capture the beauty, the drama, the fleeting perfection of the alignment. But solar eclipses are not just a spectacle. They are a lesson in perspective. They remind us that we live on a moving world, circling a star, accompanied by a moon. They show us the power of geometry, the beauty of cycles, the wonder of chance. They are a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places, that wonder is never far away. As you rest in this gentle night, let yourself imagine the experience of a total solar eclipse. Picture the moon's shadow racing across the land, the sun's light fading, the corona appearing in a burst of silver fire. Imagine the silence, the awe, the sense of being in the presence of something ancient and ever new. Let yourself wonder what it would be like to stand in the path of totality, to feel the world grow quiet, to see the stars come out in the middle of the day, to witness the beauty of alignment, the perfection of the cosmic dance. Imagine the peace that comes with patience, the wonder that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Solar eclipses are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony, in connection, in the power of nature to create order from chaos. Take another breath. Let the story of solar eclipses fill you with calm. Let the slow, patient movement of the shadows remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of eclipses, a dreamer in the endless night. Close your eyes and imagine a quiet night, the moon shining full and bright above the horizon. Its silver light bathes the world, casting gentle shadows, illuminating the landscape with a calm, familiar glow. But tonight, something is different. Slowly, a shadow begins to creep across the moon's face. The bright disk dims, turning coppery, then deep red. For a while, the moon glows like an ember in the sky, a blood moon, mysterious and beautiful. This is a lunar eclipse, a cosmic event where Earth's shadow falls upon its only natural satellite, revealing secrets about both worlds. A lunar eclipse is a dance of alignment, a moment when the sun, Earth, and moon form a straight line in space. The Earth stands between the sun and the moon, blocking the sunlight that usually bathes the lunar surface. Instead of shining with reflected sunlight, the moon is plunged into Earth's shadow, a shadow that stretches nearly 1,000,000 miles into space. There are three types of lunar eclipses: penumbral, partial, and total. In a penumbral eclipse, the moon passes through the faint outer part of Earth's shadow, dimming only slightly. In a partial eclipse, a portion of the moon enters the darker, central shadow, the umbra, creating a dramatic bite out of the lunar disk. But the most spectacular is the total lunar eclipse, when the entire moon is engulfed by the umbra, and the transformation is complete. During totality, the moon does not disappear. Instead, it glows with a deep, coppery red. This color is the result of sunlight passing through Earth's atmosphere, which bends and scatters the light, filtering out the blue and letting only the red reach the moon. It is the same effect that makes sunsets and sunrises red. The atmosphere acts as a lens, painting the moon with the colors of 1,000 dawns and dusks. The red glow of a lunar eclipse is a reminder of the connection between Earth and moon, of the way our planet shapes the light that reaches its companion. It is also a window into the state of Earth's atmosphere. If the air is clear, the moon glows bright orange or copper. If there are volcanic eruptions or dust storms, the moon may appear dark, even brown or gray. Each eclipse is a snapshot of Earth's air, a record of the planet's breath, a message written in shadow and light. Lunar eclipses are more common than solar eclipses, and they can be seen from anywhere on the night side of Earth. They are slower, more patient, lasting for hours as the shadow moves across the moon's face. The experience is gentle, meditative, a time to watch, to wonder, to feel the slow turning of the cosmos. For centuries, lunar eclipses have inspired awe and curiosity. Ancient peoples saw them as omens, messages from the gods, moments of magic and fear. In some cultures, the red moon was a sign of war or disaster. In others, a time of celebration and renewal. The Incas believed a jaguar was eating the moon. The Chinese saw a dragon devouring it. People would bang drums, light fires, and make noise to scare away the creature and bring back the light. But lunar eclipses have also been moments of discovery and understanding. The ancient Greeks noticed that Earth's shadow on the moon was always round, a clue that our planet is a sphere. The timing and frequency of eclipses helped early astronomers understand the orbits of the moon and Earth, the tilt of the lunar path, the cycles of the heavens. Today, lunar eclipses are moments of beauty and science. People gather to watch the moon turn red, to photograph the changing light, to feel the connection between Earth and sky. Scientists use eclipses to study them all. On surface, to measure the composition of Earth's atmosphere, to test the laws of physics. The gentle, predictable rhythm of lunar eclipses is a reminder that the universe is a place of order and pattern, of cycle and repetition, of beauty that comes from alignment and chance. Lunar eclipses are also a lesson in perspective. They remind us that we live on a moving world, circling a star, accompanied by a moon. They show us the power of geometry, the beauty of cycles, the wonder of chance. They are a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places, that one is never far away. As you rest in this gentle night, let yourself imagine the experience of a total lunar eclipse. Picture the moon rising full and bright, the shadow creeping across its face, the color shifting from silver to copper to deep red. Imagine the peace that comes with patience, the wonder that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to stand on the moon during an eclipse, to see the earth ringed with fire, the sun's light bending through the atmosphere, painting the lunar surface with the colors of 1,000 sunsets. Imagine the connection between worlds, the harmony of the dance, the beauty of the show. Lunar eclipses are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony, in connection, in the power of nature to create order from chaos. Take another breath. Let the story of lunar eclipses fill you with calm. Let the slow, patient movement of the shadows remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of lunar eclipses, a dreamer in the endless night. Close your eyes and imagine drifting far from Earth, out beyond the warmth of the sun, into the realm of the giant planets. Here, in the cold and darkness, the solar system's most spectacular eclipses unfold not just on Earth, but on Jupiter, Saturn, and the worlds beyond. These are eclipses on other worlds, where moons and shadows dance in ways both familiar and strange, painting the planets with moving darkness and fleeting rings of light. Begin with Jupiter, the king of the planets, orbited by more than 90 moons. 4 of these, Io, Europa, Ganymede, and Callisto, are large enough to be worlds in their own right. As they circle Jupiter, they regularly pass in front of and behind the planet, casting their shadows onto the swirling clouds below. From the surface of Jupiter, if you could stand there, you would see the sun rise and set many times a day, each time accompanied by the passage of a moon, each time marked by a moving shadow that races across the planet's face. These transits and eclipses are a regular part of Jupiter's life. The moons move in precise orbits, their paths predictable, their shadows sharp and dark. When Io passes between the Sun and Jupiter, its shadow appears as a black dot gliding across the clouds, sometimes followed by the shadows of Europa or Ganymede. These moving spots are visible even from Earth through a small telescope, a reminder that the dance of light and shadow is not unique to our world. But the view from the moons is even more dramatic. Imagine standing on the icy surface of Europa, looking up to see Jupiter filling half the sky. As the planet moves, it can eclipse the sun, plunging the moon into darkness, turning day into night, and then back again. The eclipse can last for hours, the sun hidden behind the giant planet, the sky glowing with the reflected light of Jupiter's clouds and auroras. On Ganymede, the largest moon in the solar system, the story is similar. Jupiter's shadow sweeps across the surface, creating a cycle of light and dark, a rhythm that shapes the moon's climate and history. The same is true for Callisto, where the sun is a distant, cold star, and Jupiter's eclipses are long and deep. Saturn, too, is a world of eclipses and shadows. Its rings cast broad, sweeping shadows on the planet's clouds, creating bands of darkness that move with the seasons. The moons of Saturn, Titan, Rhea, Dione, Tethys, Enceladus, and many more regularly pass in front of and behind the planet. Their shadows gliding across the rings and clouds, their orbits creating a complex ballet of light and darkness. Imagine standing on Titan, Saturn's largest moon, its thick orange atmosphere filtering the sunlight. As Saturn rises in the sky, it can eclipse the sun, turning the world into twilight, casting a ring shadow across the landscape. The rings themselves can create their own eclipses, blocking the sun, painting the surface with moving patterns of light and dark. On Enceladus, the story is even more magical. The geysers that erupt from the South Pole create plumes of ice and water, which can cast their own shadows on the surface, creating fleeting eclipses that last only moments but are a reminder of the power and beauty of the dance. Beyond Saturn, the story continues. Uranus and Neptune, with their own families of moons, experience eclipses and transits. Though the sun is faint and far, the shadows long and subtle. On Triton, Neptune's largest moon, the sun is just a bright star, but even here eclipses can occur, the planet's shadow sweeping across the frozen surface, marking the passage of time, the rhythm of the year. Eclipses on other worlds are not just a spectacle. They are a tool for discovery. By watching the shadows of moons move across the planets, astronomers can measure the orbits, the sizes, the atmospheres, and even the internal structure of these distant worlds. The timing of eclipses reveals the mass of the planet, the shape of the orbit, the presence of rings or clouds. The color and brightness of the shadow can reveal the composition of the atmosphere, the presence of haze or dust, the temperature of the clouds. Eclipses are also a source of wonder and inspiration. The images sent back by spacecraft Voyager, Galileo, Cassini, Juno show the beauty of the dance, the elegance of the patterns, the harmony of the system. The shadows of moons racing across Jupiter's clouds, the rings of Saturn casting dark bands on the planet, the fleeting darkness of an eclipse on Titan or Enceladus, all are reminders that the universe is full of surprises, that beauty can be found in the most unlikely places, that wonder is never far away. As you rest in this gentle night, let yourself imagine the eclipses on other worlds. Picture the shadows moving across Jupiter's clouds, the rings of Saturn casting patterns on the planet, the sun disappearing behind a giant world, the sky glowing with the light of auroras and clouds. Imagine the peace that comes with patience, the wonder that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to stand on a distant moon, to watch the sun rise and set behind a ringed planet, to feel the darkness of an eclipse, to see the beauty of a dance. Imagine the connection between worlds, the harmony of the orbits, the elegance of the shadows. Eclipses on other worlds are a reminder that every planet, Eve, Rai moon, every star is part of a larger story, a greater dance, a cosmic harmony that connects us all. Take another breath. Let the story of eclipses on other worlds fill you with calm. Let the slow, patient movement of the shadows remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of eclipses and shadows, a dreamer in the endless night. Close your eyes and imagine a giant planet swirling with clouds painted in bands of color. Now, picture a small dark circle gliding across its face, a shadow crisp and round, moving steadily from one edge to the other. This is the shadow of a moon cast onto its parent planet, a silent, moving mark that tells a story of orbits, light, and cosmic geometry. Tonight, let's drift into the world of moons casting shadows and discover what these transits reveal about the dance of the solar system. When a moon passes between its planet and the sun, it casts a shadow onto the planet's surface. From afar, this shadow appears as a small dark spot, gliding across the clouds, following the moon's path in perfect synchrony. These events are called transits, and they are among the most beautiful and informative phenomena in planetary astronomy. Nowhere are these transits more dramatic than on Jupiter, with its 4 large Galilean moons, Io, Europa, Ganymede, and Callisto. Jupiter is a stage for a constant ballet of shadows. As the moons orbit the planet, their shadows sweep across the cloud tops, sometimes alone, sometimes in pairs, sometimes all 4 at once. Through a telescope, these shadows are visible as inky dots moving with stately grace, marking the passage of time, the rhythm of the orbits. The shadows are not just a spectacle, they are a tool for discovery. By observing the timing and position of the shadows, astronomers can measure the orbit of the moons, the rotation of the planet, and even the structure of the clouds. The size and shape of the shadow reveal the size and distance of the moon, the angle of the sun, the curvature of the planet. The movement of the shadow is a clock, a ruler, a probe into the heart of the system. On Saturn, the story is even more intricate. The planet's rings cast their own shadows, creating bands of darkness that sweep across the clouds, changing with the seasons, marking the passage of the year. The moons of Saturn, Titan, Rhea, Dione, Tethys, Enceladus, and many more also cast shadows, their paths crossing the rings, their silhouettes moving across the planet's face. The interplay of shadows and light is a dance of complexity and beauty, a record of the orbits, the tilts, the cycles of the system. The shadows of moons are not limited to the giant planets. On Mars, the tiny moons Phobos and Deimos cast fleeting shadows during their rapid orbits, creating brief, partial eclipses that race across the surface. On Earth, our own moon casts a shadow during a solar eclipse, turning day into night, creating a moment of awe and wonder. But the story of shadows is not just about beauty, it is about knowledge. By studying the transits of moons and their shadows, astronomers have learned to measure the mass and size of planets, the distance to the sun, the tilt of the axis, the speed of rotation. The timing of transits has been used to refine the laws of gravity, to test the predictions of Newton and Einstein, to search for new moons, new rings, new worlds. Transits and shadows are also a key tool in the search for exoplanets. When a planet passes in front of its star, it casts a tiny shadow, dimming the star's light by a fraction of a percent. By measuring these dips in brightness, astronomers can detect planets around distant stars, measure their size and orbit, and even study their atmospheres. The same principles that reveal the moons of Jupiter and Saturn are now used to discover new worlds across the galaxy. The movement of shadows is a lesson in perspective. From the surface of a planet, a transit may be a fleeting eclipse, a moment of darkness as the sun is blocked by a moon. From space, the shadow is a moving spot, a mark that traces the path of the moon, a sign of the connection between worlds. The shadow is both absence and presence, both darkness and light, both mystery and revelation. Shadows are also a source of wonder. To watch a shadow move across Jupiter's clouds, to see the rings of Saturn cast lines of darkness on the planet, to witness the fleeting eclipse of Phobos on Mars, is to feel the beauty of the cosmic dance, the harmony of orbits, the elegance of geometry. The shadows are a reminder that the universe is full of patterns, that every movement has meaning, that every world is connected. As you rest in this gentle night, let yourself imagine the dance of shadows. Picture the moons moving in their orbits, their shadows gliding across the face of their planet, marking the passage of time, the rhythm of the system. Imagine the peace that comes with patience, the wonder that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to stand on the surface of Jupiter, to see the shadow of Io sweep across the clouds, to feel the darkness and the light, the beauty of the dance. Imagine the connection between worlds, the harmony of the orbits, the elegance of the shadows. Moons casting shadows are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony and connection, in the power of nature to create order from chaos. Take another breath. Let the story of shadows fill you with calm. Let the slow, patient movement of the moons in their shadows remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of moons and shadows, a dreamer in the endless night. Close your eyes and imagine a world with not just one moon but many. Picture a sky where several moons rise and set, each on its own schedule, each casting its own light and shadow, each pulling at the planet's oceans, crust, and air. This is the reality for the giant planets Jupiter, Saturn, Uranus, and Neptune, where dozens of moons orbit in a complex ballet, their gravitational pulls weaving a tapestry of tides, flexing, and motion that is far more intricate than anything we know on Earth. On Earth, the tides are shaped mostly by the pull of our single moon, with a helping hand from the sun. The result is a rhythm that is regular and predictable, 2 high tides and 2 low tides each day, the cycle repeating with the phases of the moon. But imagine if Earth had 2, 3, or even 4 large moons, each with its own orbit, its own distance, its own gravitational pull. The tides would become a symphony of overlapping cycles, sometimes reinforcing each other, sometimes canceling out, always changing, always in motion. Now travel in your mind to Jupiter, the king of the planets, orbited by more than 90 moons. 4 of these, Io, Europa, Ganymede, and Callisto, are large enough to be worlds in their own right. As they circle Jupiter, their gravity tugs only on the planet, but on each other, creating a web of resonances and tides that shapes their orbits, their interiors, and even their surfaces. The most dramatic example of this interplay is found on Io, the innermost of Jupiter's large moons. Io is caught in a gravitational tug-of-war between Jupiter and its neighboring moons, Europa and Ganymede. As Io orbits Jupiter, the gravity of Europa and Ganymede pulls it slightly out of a perfect circle, creating an elliptical orbit. This means that Io is sometimes closer to Jupiter, sometimes farther away, and the strength of Jupiter's pull changes as Io moves. This constant change in gravitational pull flexes Io's interior, squeezing and stretching it like a ball of clay. The friction created by this flexing generates heat enough to melt rock, drive volcanic eruptions, and make Io the most volcanically active world in the solar system. The tides in Io are not just in the oceans, which it doesn't have, but in the very rock itself, rising and falling by more than 1 meters, 330 feet each orbit. Europa and Ganymede, too, feel the effects of these complex tides. The flexing of their icy shells creates cracks and ridges, heats their interiors, and keeps their subsurface oceans liquid. The tides are not just a surface phenomenon, but a force that shapes the geology, the chemistry, and perhaps even the potential for life. On Saturn, the story is just as rich. The planet's many moons tie in: Rhea, Diona, Tethys, Enceladus, and Duo. Zinsmore each pull on Saturn and on each other, creating a web of tides and resonances that shapes the rings, the orbits, and the moons themselves. Enceladus, for example, is kept warm by the tidal forces created by its resonance with DNA, allowing it to maintain a subsurface ocean and erupt geysers of water ice into space. The tides created by multiple moons are not always regular. Sometimes the cycles reinforce each other, creating especially high or low tides. Other times, they cancel out, creating periods of calm. The result is a pattern that is always changing, always evolving, always full of surprises. These complex tides are not limited to the giant planets. Even on Mars, the tiny moons Phobos and Deimos create subtle tides in the thin atmosphere. The crust, their orbits slowly changing as they interact with the planet and with each other. On Pluto, the large moon Charon creates tides that have locked both worlds in a mutual embrace, each always showing the same face to the other. The study of tides in systems with multiple moons is a window into the power of gravity, the beauty of resonance, the complexity of motion. It is a reminder that the universe is not just a place of order, but of harmony. A place where cycles overlap, where patterns emerge from chaos, where every world is shaped by the company it keeps. As you rest in this gentle night, let yourself imagine the tides on a world with many moons. Picture the oceans rising and falling in complex rhythms, the crust flexing and cracking, the air moving in patterns shaped by the pull of distant satellites. Imagine the moons rising and setting, their light and shadow painting the landscape, their gravity shaping the world in ways both visible and hidden. Let yourself wonder what it would be like to live on such a world. To watch the tides change with the phases of not one, but many moons, to feel the connection between worlds, the harmony of the dance, the beauty of the cycles. Multiple moons and complex tides are a reminder that every world is unique, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony, in connection, in the power of nature to create order from chaos. Take another breath. Let the story of tides and moons fill you with calm. Let the slow, patient movement of the satellites remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of tides and moons, a dreamer in the endless night. Close your eyes and imagine a planet spinning in the darkness, its axis tilted at a gentle angle, its poles capped with ice, its equator warm and bright. The seasons come and go, the climate is stable, and life flourishes. But what keeps this balance? What prevents the planet from tipping too far, from wobbling wildly, from swinging between extremes of heat and cold? The answer, in many cases, is a moon, a silent guardian, a stabilizer, a partner in the cosmic dance. The tilt of a planet's axis, known as obliquity, is one of the most important factors in determining its climate. On Earth, the axis is tilted by about 23.5 degrees, giving rise to the season, the cycle of summer and winter, the gentle rhythm of change that shapes the world. But this tilt is not fixed. Over time, it can change, wobbling back and forth, sometimes by a few degrees, sometimes by much more. These wobbles, called axial precession and nutation, are caused by the gravitational pull of other bodies, most notably the Sun and the planet's own moon. Without a stabilizing influence, a planet's tilt can vary chaotically, leading to dramatic swings in climate, the rise and fall of ice ages, the waxing and waning of deserts and forests. On Earth, our moon plays a crucial role in keeping the planet's tilt stable. The moon's gravity pulls on the bulge of Earth's equator, resisting the tugs of the Sun and other planets, damping the wobbles, and keeping the tilt within a narrow range. This stability has been essential for the development and persistence of life, allowing the climate to remain relatively mild and predictable over millions of years. Without the moon, Earth's tilt could vary by as much as 60 degrees, swinging from upright to nearly sideways, turning the poles toward the Sun, baking the equator, freezing the continents, and making life as we know it impossible. The moon is not just a companion, but a guardian, a partner in the dance of stability and change. But not all planets are so lucky. Mars, for example, has only 2 tiny moons, Phobos and Deimos, too small to have much effect on the planet's tilt. As a result, Mars's obliquity varies wildly over time, swinging from nearly 0 to more than 60 degrees. These changes drive dramatic shifts in climate, the advance and retreat of polar ice, the waxing and waning of dust storms, the rise and fall of ancient lakes and rivers. The giant planets Jupiter, Saturn, Uranus, and Neptune have many moons, but their great mass and rapid rotation make their tilts more stable. Uranus, however, is a special case. Its axis is tilted by 98 degrees, lying almost in the plane of its orbit, giving rise to extreme seasons, with each pole spending decades in darkness or sunlight. The cause of this tilt is still debated, but it may be the result of a giant impact long ago, a collision that knocked the planet onto its side, forever changing its climate and history. Moons can also destabilize a planet's tilt, especially if they are large and close. The gravitational interactions between a planet and its moons can create resonances, amplify wobbles, and drive changes in obliquity. In some cases, these changes can be beneficial, creating cycles that drive evolution and adaptation. In others, they can be catastrophic, leading to mass extinctions, the loss of atmosphere, the end of habitability. The study of moons and planetary wobbles is a window into the deep history of the solar system. By measuring the tilt of a planet's axis, the size and orbit of its moon, and the patterns of its climate, scientists can reconstruct the past, predict the future, and understand the delicate balance that makes life possible. Moons are not just stabilizers, they are also storytellers. Their presence or absence, their size and distance, their orbits and interactions, all shape the fate of their planet. The moon has shaped Earth's history. Mars's lack of a large moon has shaped its climate. Uranus's tilt has shaped its seasons. And the moons of the giant planet have shaped their rings, their weather, their evolution. As you rest in the gentle night, let yourself imagine the dance of moons and planetary wobbles. Picture the Earth spinning in space, its axis held steady by the moon, its climate mild and stable, its seasons gentle and predictable. Imagine Mars, its tilt swinging wildly, its climate changing, its history written in ice and dust. Imagine Uranus lying on its side, its poles basking in sunlight, its equator locked in darkness. Let yourself wonder what it would be like to live on a world without a stabilizing moon, to see the sun rise at the pole, to watch the seasons change in unpredictable ways, to adapt to a climate that is always in flux. Imagine the peace that comes with stability, the challenge that comes with change, the beauty that comes with the dance. Moons and planetary wobbles are a reminder that every word is unique, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony, in connection, in the power of nature to create order from chaos. Take another breath. Let the story of moons and planetary wobbles fill you with calm. Let the slow, patient movement of the satellites remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of moons and planetary wobbles, a dreamer in the endless night. Close your eyes and imagine a planet spinning in the darkness, its surface alive with oceans, continents, and clouds. Now, picture a moon circling, that planet a companion, a partner, a silent influence that shapes the world below in ways both subtle and profound. The story of moons is not just a story of orbits and tides, but a story of evolution, of change, of the long, patient unfolding of planetary history. Moons are more than just satellites. They are architects of climate, sculptors of coastlines, drivers of geological activity, and even guardians of habitability. Their influence reaches deep into the heart of our planets, shaping the conditions that make life possible, guiding the evolution of worlds over billions of years. On Earth, the moon's influence is everywhere. Its gravity creates the tides, the gentle rise and fall of the oceans that shape coastal Venus, nourish ecosystems, and drive the migrations of countless species. The tides mix the waters, distribute heat, and create habitats for life at the boundary of land and sea. Without the moon, Earth's tides would be weaker, the oceans less dynamic, the diversity of life diminished. But the moon's greatest gift to Earth may be its role as a stabilizer. The moon's gravity pulls on the bulge of Earth's equator, keeping the planet's tilt steady, moderating the climate, and making the seasons regular and predictable. Without the moon, Earth's tilt would wobble chaotically, swinging between extremes, turning the poles toward the sun, baking the equator, freezing the continents. The climate would be unstable, the seasons unpredictable, the conditions for life far less favorable. The moon has also shaped Earth's history through its role in the planet's formation. The leading theory is that the moon was born from a giant impact, when a Mars-sized body struck the young Earth, blasting material into orbit. This debris coalesced to form the moon. while the energy of the impact melted and mixed Earth's crust and mantle, creating a world with a unique composition, dynamic geology, and a magnetic field that protects life from cosmic radiation. Moons can also drive geological activity on their planets and themselves. The tidal forces created by a moon's gravity can flex a planet's crust, creating heat, driving volcanism, and shaping the surface. On Jupiter's moon Io, tidal heating Fr. Jupiter and the other Galilean moons powers hundreds of active volcanoes, making Io the most geologically active world in the solar system. On Saturn's moon Enceladus, tidal heating keeps a subsurface ocean liquid, driving geysers that spew water into space and hint at the possibility of life. Moons can also influence the evolution of a planet's atmosphere. The impact that formed Earth's moon may have stripped away a thick, primordial atmosphere, allowing the planet to cool and stabilize. The presence of a large moon can also help a planet retain its atmosphere by stabilizing its tilt and reduce the loss of gases to space. The role of moons in planetary evolution is not limited to Earth. Mars, with its tiny moons Phobos and Deimos, lacks a stabilizing influence, and its tilt wobbled wildly over time, driving dramatic changes in climate and the advance and retreat of polar ice. The giant planets, with their many moons, experience complex interactions that shape their rings, their weather, and their long-term evolution. Moons can also be sites of habitability in their own right. The icy moons of Jupiter and Saturn, Europa, Ganymede, and Enceladus, Titan may harbor subsurface oceans, kept warm by tidal heating, protected from radiation by thick shells of ice. These oceans are among the most promising places to search for life beyond Earth, worlds where energy, water, and chemistry come together in the darkness. The story of moons and planetary evolution is a story of connect. Ion, of influence, of the quiet power of companionship. Moons are not just passive followers, but active partners, shaping the fate of their planets, guiding their history, making life possible in ways both seen and unseen. As you rest in this gentle night, let yourself imagine the long, patient influence of a moon on its planet. Picture the tides rising and falling, the seasons turning, the climate stabilizing, the surface changing, the atmosphere evolving. Imagine the peace that comes with stability, the wonder that comes with discovery, the hope that comes with knowing that you are part of a universe where every world is shaped by the company it keeps. Let yourself wonder what it would be like to live on a world without a moon, to see the climate swing between extremes, to watch the seasons change unpredictably, to adapt to a world in constant flux. Imagine the beauty that comes with connection, the strength that comes with partnership, the resilience that comes with companionship. The role of moons in planetary evolution is a reminder that every world is unique, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony and connection, in the power of nature to create order from chaos. Take another breath. Let the story of moons and planetary evolution fill you with calm. Let the slow, patient movement of the satellites remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of moons and planets, a dreamer in the endless night. Close your eyes and imagine a world before science, before telescopes, before the language of gravity and orbits. The night sky is a canvas of mystery, the moon a glowing companion, the sun a source of life and power. Suddenly, the moon turns red, or the sun is swallowed by darkness in the middle of the day. The world changes, and people gather in awe and fear and wonder. These are the moments when myths are born, when legends are told, when the dance of the moons and the shadows of eclipses become stories that shape cultures and connect generations. Throughout history, eclipses and the movements of the moon have inspired countless myths and legends. In every corner of the world, people have looked up and tried to make sense of these rare and powerful events. The stories they told are as diverse as the cultures themselves, but all share a sense of awe, a recognition of the beauty and mystery of the cosmos. In ancient China, a solar eclipse was seen as a dragon devouring the sun. People would bang drums, light fires, and make noise to scare the dragon away, to bring back the light. The eclipse was a moment of danger, a time when the balance of the world was threatened, a reminder of the power of the heavens. In India, eclipses were explained as the demon Rahu swallowing the sun or moon. According to legend, Rahu was beheaded by the gods, but his immortal head continued to chase the sun and moon, occasionally catching them and causing an eclipse. Rituals and prayers were performed to protect against the negative effects of the event, and people would fast, bathe, and avoid eating during the eclipse. In Norse mythology, the sun and moon were chased by wolves Skoll and Hati, who would sometimes catch and devour them, plunging the world into darkness. The end of the world, Ragnarok, would be marked by the final swallowing of the sun and moon, a cosmic battle between light and shadow. In the Americas, the Inca believed that a lunar eclipse was caused by a jaguar attacking and eating the moon. To prevent disaster, people would shout, shake their spears, and make noise to drive the jaguar away. The Maya, master astronomers, could predict eclipses with great accuracy, but still saw them as moments of transformation, times when the boundaries between worlds grew thin. In Africa, the Batamaliba people of Togo and Benin saw a lunar eclipse as a time of conflict between the sun and moon. The people would come together to encourage the celestial bodies to resolve their differences, using the eclipse as a moment for reconciliation and forgiveness in their own lives. In North America, the Hupa and Luiseno tribes believed that the moon had 20 wives and many pets, and that a lunar eclipse occurred when the moon neglected his duties and was attacked by animals. The people would sing and pray to He. LP the moon recover and return to his place in the sky. In Europe, eclipses were often seen as omens, warnings of disaster, death, or change. Kings and queens consulted astrologers, armies delayed battles, and common people watched in fear and fascination as the sky darkened and the familiar order of the world was upended. But not all myths were fearful. In some cultures, eclipses were moments of celebration, of renewal, of connection to the divine. The Japanese saw a solar eclipse as a time when the sun goddess Amaterasu hid in a cave, and the people would dance and sing to lure her back. In Polynesia, the moon was a goddess who visited the earth, her phases marking the passage of time. Her eclipses, moments of magic and transformation. The moon itself has inspired countless stories, poems, and songs. Its phases mark the months. Its cycles guide the planting and harvesting of crops. Its light illuminates the night and inspires dreams. The man in the moon, the rabbit in the moon, the woman in the moon, all are reflections of the human desire to find meaning in the sky, to connect the heavens and the earth, to make sense of the mysteries above. Eclipses and the dance of the moons are not just scientific events. They are moments of wonder, of fear, of hope, of connection. They remind us that we are part of a universe that is both beautiful and mysterious, that our stories are woven into the fabric of the cosmos, that the movements of the heavens shape our lives in ways both seen and unseen. As you rest in this gentle night, let yourself imagine the myths and legends of eclipses and moons. Picture people gathered around fires, telling stories of dragons and demons, wolves and jaguars, gods and goddesses. Imagine the awe and wonder, the fear and hope, the sense of connection to something greater than themselves. Let yourself wonder what stories you would tell, what myths you would create, what meaning you would find in the dance of the moons and the shadows of eclipses. Imagine the peace that comes with wonder, the beauty that comes with mystery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Myths and legends of eclipses and moons are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of the human mind to find meaning in the stars. Take another breath. Let the story of myths and eclipses fill you with calm. Let the slow, patient movement of the shadows remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of moons and legends, a dreamer in the endless night. Close your eyes and imagine a world far from the warmth of the sun, a moon circling a giant planet. In the cold, dark reaches of the solar system, the surface is frozen, silent, and still. But beneath the ice, something extraordinary is happening. A hidden ocean, warmed not by sunlight, but by the gentle, persistent kneading of gravity. This is the story of moons and the search for life, a story that is changing our understanding of where life can exist and what it means to be alive in the universe. For centuries, we believed that life could only thrive in the habitable zone, the narrow band, or a star where temperatures are just right for liquid water to exist on a planet's surface. Earth, with its oceans and atmosphere, seemed unique, a rare oasis in a vast, empty desert. But the discovery of subsurface oceans on moons like Europa and Enceladus has rewritten the rules, expanding the possibility, opening new doors to wonder. Europa, one of Jupiter's 4 large Galilean moons, is a world of ice and mystery. Its surface is smooth and bright, crisscrossed by dark lines and ridges, evidence of a restless, shifting shell. Beneath that shell, scientists believe, lies a global ocean twice as much water as all of Earth's ocean combined, kept liquid by the heat generated as Europa is flexed and squeezed by Jupiter's gravity. This process, called tidal heating, is a quiet engine, a source of energy that powers the movement of the ice, the creation of cracks and ridges, and perhaps even the chemistry of life. Enceladus, a small moon of Saturn, is another world of hidden water. Its surface is bright and icy, marked by long blue fractures called tiger stripes. From these fractures, geysers of water and ice erupt into space, creating a plume that feeds Saturn's E-ring and hints at a subsurface ocean beneath the ice. The heat that drives these geysers comes from tidal flexing, as Enceladus is pulled and squeezed by Saturn and its neighboring moons. The Cassini spacecraft flew through these plumes, sampling the water and finding organic molecules building blocks of life mixed with the ice. The importance of these discoveries cannot be overstated. On Earth, wherever there is water, there is life. In the deepest oceans, around hydrothermal vents, life thrives in darkness, feeding on chemical energy rather than sunlight. The same could be true on Europa, Enceladus, and other icy moons. If their oceans contain the right ingredients, water, energy, and organic molecules, then life could exist, hidden beneath the ice, waiting to be discovered. The search for life on these moons is one of the most exciting frontiers in science. Future missions like NASA's Europa Clipper and ESA's JUICE will explore these worlds in detail, mapping their surfaces, probing their oceans, searching for signs of habitability and, perhaps, life itself. The dream is to one day send a lander, a probe that can melt through the ice, dive into the ocean, and search for living organisms, an encounter that would change our understanding of life in the universe forever. But the store, why does not end with Europa and Enceladus? Other moons, Ganymede, Callisto, Titan, may also harbor subsurface oceans, kept warm by tidal heating, protected from radiation by thick shells of ice. Even Pluto, far beyond the reach of the sun's warmth, may have a hidden ocean beneath its frozen surface. The universe is full of surprises, and the possibilities for life are greater than we ever imagined. Tidal heating is the key to these hidden worlds. It is a process that requires only gravity and motion, not sunlight or proximity to a star. As a moon orbits its planet, the gravitational pull changes, flexing the moon's interior, generating heat, melting ice, driving chemistry. The result is a world that is alive, dynamic, and full of potential, a world where life could exist in the darkness, feeding on chemical energy, evolving in ways we can only dream of. The search for life on moons is a story of hope, of curiosity, of the power of science to expand our horizons. It is a reminder that life is resilient, adaptable, and creative, that it can thrive in the most unlikely places, that the universe is full of possibilities. As you rest in this gentle night, let yourself imagine the hidden oceans of Europa and Enceladus. Picture the ice above, the water below, the heat rising from the core, the chemistry unfolding in the darkness. Imagine the possibility of life, simple or complex, familiar or strange, thriving in the depths, waiting to be discovered. Let yourself wonder what it would be like to explore these worlds, to dive beneath the ice, to search for signs of life, to feel the excitement of discovery, the joy of connection, the hope of finding that we are not alone. Moons and the search for life are a reminder that every world is unique, that every story is worth telling, that beauty can be found in the quiet, in the patient, and the enduring. The dance of the moons is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of life to find a way, even in the darkness, Take another breath. Let the story of moons and the search for life fill you with calm. Let the slow, patient movement of the satellites remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of moons and oceans, a dreamer in the endless night. Close your eyes and imagine a world before clocks, before calendars, before the ticking of seconds and the counting of days. The only timekeeper is the sky, and the most faithful of all is the moon. Night after night, the moon waxes and wanes, growing from a thin crescent to a full glowing disk, then shrinking again to darkness. This cycle, so regular and so visible, has guided humanity for tens of thousands of years. The moon is not just a companion in the night, it is the world's oldest clock, the first calendar, the silent keeper of time. Long before the invention of writing, ancient people watched the moon's phases and marked their passing. They noticed that the time from one new moon to the next, about 29.5 days, was always the same. This period, called a lunar month, became the basis for the earliest calendars. The waxing and waning of the moon was a natural way to divide time, to measure the passage of days, to plan for the future. The moon's cycle is easy to see even without tools. The new moon is invisible, lost in the sun's glare. A few days later, a thin crescent appears in the evening sky, growing fatter each night. After about a week, the moon is half full of first quarter. A week later, it is full, rising at sunset and shining all night. Then it begins to shrink, passing through the last quarter, returning to a crescent, and finally disappearing again. This rhythm, repeated 12 or 13 times a year, is the heartbeat of the sky. Many ancient cultures built their calendars around the moon. The Babylonians used a lunar calendar with months beginning at the first sighting of the crescent moon. The Hebrew calendar, still used for religious purposes today, is based on lunar months, with occasional adjustments to keep it in sync with the solar year. The Islamic calendar is purely lunar, with months that drift through the seasons, each beginning with the new crescent. The Chinese calendar is lunisolar, combining lunar months with solar years so that festivals and seasons stay aligned. The Maya tracked the moon cycles with incredible precision, using them to predict eclipses and mark the passage of time. The ancient Egyptians used a lunar calendar for religious festivals, while the Greeks and Romans named their months after the moon's phases. The moon's role as a timekeeper is not just practical, it is also poetic. The phases of the moon are woven into myths and stories, rituals and celebration. The new moon is a time of beginnings, the full moon a time of fullness and completion, the waning moon a time of endings and reflection. Many cultures hold festivals at the full moon, harvests, dances, prayers, and feasts, all guided by the moon's gentle light. The moon's cycles also shape the rhythms of life. The tides, driven by the moon's gravity, rise and fall with the phases, guiding the migrations of fish, the nesting of turtles, the flowering of plants. Some animals, like the palolo worm of the South Pacific, time their reproduction to the full moon, releasing eggs and sperm in a synchronized dance that fills the sea with new life. For early humans, the moon was a guide and a guardian. Its light made travel and hunting possible at night. Its cycles marked the best time for planting and harvesting. Its phases were used to count the days between events. The moon's regularity was a comfort, a sign that the world was ordered, that time could be measured, that the future could be known. The moon's role as a timekeeper is also a lesson in patience. The cycle is slow, measured in weeks and months, not hours in them, in newts. It teaches us to wait, to watch, to trust in the rhythm of nature. The moon's phases are a reminder that time is not just a number, but a pattern, a dance, a story that unfolds in the sky. Even today, in a world of atomic clocks and digital calendars, the moon's influence endures. Many holidays and festivals are still set by the lunar calendar: Easter, Ramadan, Passover, the Chinese New Year, the Mid-Autumn Festival. Farmers still watch the moon to guide their planting. Fishermen still follow the tides. Lovers still walk by moonlight. Poets still write of the moon's beauty and mystery. The moon's cycles are also a source of wonder. To watch the crescent grow, to see the full moon rise, to witness an eclipse or a blue moon, is to feel the connection between earth and sky, between past and present, between the rhythms of nature and the rhythms of life. As you rest in this gentle night, let yourself imagine the moon as a timekeeper. Picture the phases waxing and waning, the months passing, the years unfolding. Imagine the ancient peoples watching the sky, marking the days, planning their lives, telling their stories by the light of the moon. Let yourself wonder what it would be like to live by the moon's calendar, to feel the passage of time in the changing light, to trust in the rhythm of the sky, to find comfort in the regularity of the cycle. The moon as a timekeeper is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet and the patient and the enduring. The dance of the moons is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of the human mind to find meaning in the stars. Take another breath. Let the story of the moon's cycles fill you with calm. Let the slow, patient movement of the phases remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of the moon and time, a dreamer in the endless night. Close your eyes and imagine the moon, high above the horizon, shining softly on a quiet night. For billions of years, it has circled the earth, pulling at the oceans, guiding the tides, marking the months, and creating the beautiful spectacle of eclipses. But the moon's dance is not static. It is slowly, almost imperceptibly, changing. With each passing year, the moon drifts a little farther away from Earth and the future of time, and eclipses is quietly, patiently being rewritten. The story begins with the tides. As the moon orbits Earth, its gravity pulls on the oceans, creating bulges of water on the side facing the moon and the side opposite. As Earth spins, these bulges move around the planet, creating the familiar cycle of high and low tides. But the tides are not perfectly aligned with the moon, because Earth rotates faster than the moon orbits. The tidal bulge is carried slightly ahead of the moon's position in the sky. This offset creates a subtle but powerful effect. The gravitational pull between the tidal bulge and the moon acts like a giant brake, slowing Earth's rotation and transferring energy to the moon. As a result, Earth's days are gradually getting longer by about 2 milliseconds per century, and the moon is slowly moving away, receding at a rate of about 3.8 centimeters, 1.5 inches per year. It's a tiny change, almost impossible to notice in a single lifetime. But over millions and billions of years it adds up. When the moon first formed, it was much closer to Earth, perhaps only 22,000 kilometers away, compared to the current 384,000 kilometers. The tides were much higher, the days much shorter, and the moon loomed large in the sky. As the moon moves away, the tides on Earth are gradually becoming weaker. The gravitational pull is less, the bulges are smaller, and the energy exchanged between Earth and moon is reduced. In the distant future, the tides will be gentler, the rhythm of the ocean slower, the connection between Earth and moon more tenuous. But the most dramatic consequence of the moon's retreat is the fate of eclipses. Right now, the moon is just the right size and distance to perfectly cover the sun during a total solar eclipse. The apparent diameters of the sun and moon in the sky are almost exact the same, creating the breathtaking spectacle of totality, the corona shining, the sky darkening, the world transformed. But as the moon moves away, its apparent size in the sky shrinks. In about 600 million years, the moon will be too far from Earth to completely cover the sun. Total solar eclipses will become impossible. Only annular eclipses, where a ring of sunlight remains visible around the moon, will occur. The era of totality, of the perfect alignment, will come to an end. Lunar eclipses, too, will change. As the moon recedes, it will spend less time in Earth's shadow, and the eclipses will be shorter and less dramatic. The red glow of the blood moon will fade, the spectacle will become rarer, the connection between Earth and moon more distant. The slow retreat of the moon is a reminder that nothing in the universe is permanent. The dance of the tides, the beauty of eclipses, the rhythm of the months, all are changing, all are evolving, all are part of the long, patient unfolding of time. But the story is not one of loss alone. The moon's retreat is also a story of balance, of harmony, of the quiet power of gravity to shape the fate of worlds. The energy lost by Earth's rotation is not wasted, it is transferred. to the moon, raising its orbit, keeping the dance alive, ensuring that the connection endures even as the distance grows. The future of tides and eclipses is also a story of wonder. For now, we live in a golden age, a time when the moon is just the right distance to create the most beautiful eclipses, the most dramatic tides, the most perfect alignment. We are witnesses to a moment in cosmic history, a fleeting era that will not last, a gift to be cherished and remembered. As you rest in this gentle night, let yourself imagine the future of the moon's dance. Picture the tides growing gentler, the days growing longer, the moon shrinking in the sky, the eclipses fading into memory. Imagine the peace that comes with patience, the beauty that comes with change, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to live in a distant future, to see the moon as a small, distant companion, to remember the days of total eclipses, to tell stories of the time when the moon and sun were perfectly matched. Imagine the connection between worlds, the harmony of the orbits, the elegance of the dance. The future of tides and eclipses is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet and the patient and the enduring. The dance of the moons is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of time to change everything. Take another breath. Let the story of the moon's retreat fill you with calm. Let the slow, patient movement of the satellites remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of tides and eclipses, a dreamer in the endless night. Close your eyes and imagine a moonlit night, the world bathed in silver, the shadows long and soft, the air filled with a quiet magic. For as long as humans have looked up at the sky, the moon and its dance of light and shadow have inspired artists, poets, musicians, and dreamers. The moon is not just a celestial body, it is a muse, a symbol, a canvas for the imagination. Its phases, eclipses, and tides have shaped the stories we tell, the songs we sing, and the art we create. In art, the moon has been painted, sculpted, and drawn in every style and every era. Ancient cave artists scratched its crescent shape onto stone, marking the passage of time, the rhythm of the months. In classical paintings, the moon glows above landscapes and lovers, a symbol of romance, mystery, and longing. The Japanese woodblock masters captured the moon's reflection on water, its light on cherry blossoms, its presence in the quiet of the night. The moon's phases have been a favorite subject for artists, each stage carrying its own meaning. The new moon is a symbol of beginnings, the full moon of fulfillment, the waning moon of endings and reflection. The crescent moon hanging low in the sky is a sign of hope, of dreams yet to be realized, of journeys yet to begin. Eclipses, too, have inspired awe and creativity. The sudden darkness of a solar eclipse, the blood-red glow of a lunar eclipse, the dance of shadows across the land. These are moments that artists have tried to capture, to hold, to share. In ancient times, eclipses were painted on pottery, carved into monuments, woven into tapestries. In modern times, they are photographed, filmed, and shared around the world. Their beauty a reminder of the power of nature and the wonder of the cosmos. In literature, the moon is a symbol of change, of cycles, of the passage of time. Poets have written of its beauty, its mystery, its influence on the heart and mind. Shakespeare called the moon the sovereign mistress of true melancholy, a companion to lovers and dreamers, a witness to the secrets of the night. The moon appears in myths and legends from every culture, a goddess, a trickster, a guardian, a guide. The moon's shadows have inspired stories of magic and transformation. In fairy tales, the moon is a portal to other worlds, a place where wishes are granted, where dreams come true. In science fiction, the moon is a destination, a frontier, a home for future explorers. Writers imagine cities beneath its surface, gardens in its craters, civilizations that rise and fall with the tides. The moon's influence on music is just as profound. Composers have written symphonies and sonatas inspired by its light and movement. Beethoven's Moonlight Sonata captures the quiet beauty of a lunar night, its notes gentle and haunting, its rhythm slow and patient. Debussy's Clair de Lune is a musical painting, a reflection of moonlight on water, a dance of shadows and dreams. Folk song and lullabies celebrate the moon as a friend and protector, a light in the darkness, a guide for travelers and lovers. Jazz musicians improvise under the full moon. Rock bands sing of moonlit nights. Pop stars dream of dancing in the moonlight. The moon's presence in music is universal. Its inspiration endless, its beauty timeless. The moon's role in creativity is not just symbolic, it is practical. Its phases have guided the timing of festivals, the planting of crops, the setting of rituals and celebration. The full moon is a time for gathering, for storytelling, for dancing and singing. The new moon is a time for reflection, for planning, for dreaming of what is to come. The moon's shadows, too, have inspired art and science alike. The patterns of light and dark on the lunar surface, the changing shapes of the phases, the fleeting darkness of an eclipse, all are reminders of the interplay between light and shadow, between presence and absence, between what is seen and what is hidden. As you rest in this gentle night, let yourself imagine the moon as a muse. Picture the artist painting its light, the poets writing its stories, the musicians playing its song. Imagine the peace that comes with beauty, the wonder that comes with mystery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what stories you would tell, what songs you would sing, what art you would create, inspired by the moon and its shadows. Imagine the connection between worlds, the harmony of the dance, the elegance of the light. Moons in art, literature, and music are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet and the patient and the enduring. The dance of the moons is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of the human mind to find meaning in the stars. Take another breath. Let the story of the moon's inspiration fill you with calm. Let the slow, patient movement of the satellites remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of moons and creativity, a dreamer in the endless night. Close your eyes and imagine the solar system as a grand ballroom, vast and silent, swept clean by the winds of time. In this ballroom, every planet, every moon, every ring and shadow is a dancer, moving in harmony with the music of gravity. The dance is slow and patient, measured in days and years, centuries and eons. Yet it is a dance that connects every world, every ocean, every shadow in a universal choreography that is both ancient and ever new. Tides, eclipses, and shadows are not isolated phenomena. They are the visible signs of a deeper connection, the threads that weave the fabric of the cosmos. The pull of a moon on its planet, the alignment of worlds in an eclipse, the movement of shadows across clouds and rings, these are the steps in a dance that has no beginning and no end. Tides are the heartbeat of the dance. On Earth, the moon's gravity pulls at the oceans, creating bulges of water that move around the planet as it spins. The sun joins the dance, adding its own pull, creating cycles of spring and neap tides. The tides shape coastlines, nourish life, and mark the passage of time. But tides are not unique to Earth. On Jupiter's moon Io, tides flex the very rock, driving volcanoes that light the night. On Europa and Enceladus, tides keep oceans liquid beneath shells of ice, creating the conditions for life in the darkness. Eclipses are the moments when the dance becomes visible, when the alignment of worlds creates a spectacle of light and shadow. A solar eclipse, when the moon passes between Earth and the sun, turns day into night, revealing the sun's hidden corona. A lunar eclipse, when Earth's shadow falls on the moon, turns it red, painting the sky with the colors of 1,000 sunsets. Eclipses happen on other worlds, two moons casting shadows on Jupiter and Saturn, rings creating bands of darkness, planets and moons aligning in a cosmic ballet. Shadows are the brushstrokes of the dance, painting patterns on planets and rings, marking the passage of time, revealing the structure of the size. The shadow of a moon gliding across Jupiter's clouds, the rings of Saturn casting light of darkness on the planet, the fleeting eclipse of Phobos on Mars, all are reminders that every world is connected, every orbit is part of a larger pattern, every shadow is a sign of the dance. The universal dance is a lesson in harmony. The orbits of moons and planets are not random, but ordered shape by gravity, by resonance, by the slow, patient unfolding of time. The cycles of tides and eclipses repeat with a regularity that is both comforting and awe-inspiring. The patterns of shadows and light are a record of the connections between worlds, a visible sign of the invisible forces that bind the universe together. The dance is also a lesson in change. Orbits evolve, tides shift, eclipses come and go, shadows move and fade. The dance is never static, never finished, always unfolding. The beauty of the dance lies in its impermanence, its unpredictability, its endless capacity for surprise. The universal dance is a lesson in connection. Every world is part of the system. Every moon shapes its planet, every planet shapes its moons. The tides on Earth are linked to the moon, the eclipses to the alignment of sun, earth, and moon, the shadows to the movement of light across space. The dance is a web of relationships, a network of influence, a tapestry of cause and effect. The dance is also a lesson in humility. For all our knowledge, all our technology, all our exploration, the dance remains mysterious, its patterns more complex, its beauty more profound, its meaning deeper than we can fully grasp. The dance reminds us that we are part of something greater, that our lives are woven into the fabric of the cosmos, that our stories are echoes of a universal rhythm. As you rest in this gentle night, let yourself imagine the universal dance. Picture the planets and moons moving in their orbits, the tides rising and falling, the eclipses marking the passage of time, the shadows painting patterns on clouds and rings. Imagine the peace that comes with harmony, the wonder that comes with connection, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to see the dance from afar, to watch the solar system move as one, to feel the beauty of the patterns, the elegance of the steps, the music of gravity. Imagine the connection between worlds, the harmony of the orbits, the elegance of the shadows. The universal dance is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the moons is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of the human mind to find meaning in the stars. Take another breath. Let the story of the universal dance fill you with calm. Let the slow, patient movement of the planets and moons remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of tides, eclipses, and shadows, a dreamer in the endless night.